Hello friends, welcome to TechEJ YouTube channel. Friends, in today's video we are going to do hands-on labs on Kubernetes networking. Okay, so this video will be mostly focused on the practical aspect of Kubernetes networking. This video gonna do the episode 6 of Kubernetes Master 0 to Hero series that is being uploaded in my YouTube channel TechEJ. Okay, so let's quickly discuss the main Kubernetes components and then we will go deeper inside Kubernetes networking and do the practicals. Okay, so as we earlier discussed, these are the main component control plane and worker node. Okay, so Kubernetes are based on the master and slave architecture. Okay, so there will be some nodes that work as a control plane, there will be some nodes that work as a worker, and also same time you can configure your cluster to work as a control plane or worker node at the same time. Okay, for that you can untent the master nodes. Okay, so main components of control plane are API server, etcd, scheduler and control manager, and their specific roles I already explained, just I will quickly go through that. Like API server is the entry point for all the commands, okay, like which you run, like kubectl apply or any other commands. It means all commands that you run goes to the API server. So it means this API server work as an architect. Okay, so etcd is the key value data store, it is the vault basically. Okay, and the scheduler assign pods to node. It's a work like a dispatcher, and controller manager is maintains state like nodes, replica, etc. It means desired state. Okay, so it's you can think like a guard. And here worker node are worker node have three main components, that is kubelet, kubeproxy, controller, container runtime. Okay, so kubelet ensure containers are running all the time. Okay, so these are the main you can think as a foreman, okay, working at your site, actual site. And kubeproxy is basically interpreter, you can say, the traffic controller. It's always communicate with in sync with the API servers. Okay, and translate like what our architect want to do here on our worker node. Okay, container runtime basically provide the runtime engine, like it can be Docker-D, Container-D, Cryo-D. Okay, also here it can be cryo. Okay, so it's the actual engine, you can think that. So let's come into the networking. Okay, so here, so as I already discussed, the main brain behind the Kubernetes networking is the CNI itself. Okay, so there are multiple provider of CNI. Okay, so this will be the our in our practical we will mainly use the planar. Okay, so planar is not mostly used in enterprise, it's just used for the mostly for the learning the concept. Okay, and for development purpose. Okay, so it's basically CNI, container network interface, provide the network stack to the Kubernetes. Okay, so it's you can think it's as a brain, and netlink API are called behind the scene. Okay, so these are the main interfaces between user space and kernel. Okay, so any CNI provider, either it's planar or any other, you can think there are multiple CNI providers, all basically uses the netlink API. Okay, so it's basically the main nervous system, you can think. If you take example of our body, then CNI is the basically the brain, netlink API is the nervous system, like how your commands or request or response will travel to the kernel. Okay, it's basically APIs, that is the netlink API. It's you can think as a nervous system, and actually the Linux kernel here work as a muscle to give the power, actual power to all the things happen. Okay, so it's basically do multiple things. Here it's written like packet forwarding and view excellence, like multi other things Linux kernel do. It means this is the actual things, actual power, like in our body muscle provide the actual power. Okay, So you can think like that. So let's discuss. Here we will discuss the 4 core pillars or 4 core concepts of networking that is basically required here. Like we will require the intra-pod communication. Okay, that is like if our single pod has multiple containers or sidecar containers, then it will communicate by the local host, as we already discussed in theoretical topic. Okay, and Internode pod networking, it means from pod A of node 1 between pod B of node 2 will mainly communicate by the overlay network that is provided by the CNI. Okay, it all things are like here also it's implemented by CNI, but it's here communicate by using the local host, or you can say pod's namespaces here. Pod namespace, its usage basically pod namespace. Okay, but here 2 main thing will interact. Those are the root namespace and another one is the obviously pod namespace. Okay, so third is the service networking. Okay, so here it's like Kubernetes has some services for the providing the networking. Like if you want to access from outside to inside the cluster, then you can use the node port. If you want to do the internal communication, then VIP will be internal communication within the cluster, then VIP will be used, and load balancer will be used to really distribute the network traffic between the nodes. Okay, so here we will going to do the and see all the things practically. Okay, so here we will basically unwrap all the packets and we'll trace the packets by using the Wireshark and TCP dump. We will see how actually complete Kubernetes networking work behind the scene. Okay, so these are some important points that you need to know before going into deep practical session. Okay, so here you can think the like CNI is the brain and orchestrating the logic with kubelet, netlink is the nervous system, and the high-speed API that carries those instructions, and the Linux kernel is the muscle doing the actual heavy lifting of moving every single bit across the wire. Okay, means the brain decides and nervous system basically iterate, sends instruction where it's required to the kernel or to the user space, and the kernel does the actual heavy lifting by moving the bits. Okay, so here are the core components that are working here inside the worker node. Okay, kubelet, netlink API, Linux kernel, kubeproxy. Okay, so what kubelet basically do? It's basically like our kubeproxy is already taking, like kubelet is the first thing that basically install and sit in every node. Okay, so it's call to kubeproxy, and kubeproxy in connection with the CNI itself work. Okay, so here multiple things are working concurrently. Okay, so let's go into our practical session. So here let me uncover my lab here first of all. So when you see here, let me first also I have 3 nodes. Okay, I have 3 nodes. Okay, having this version, these are, you can see that all are running on Red Hat Enterprise Linux 9.7. Okay, so all nodes has RHEL 9.7 installed on that, and all nodes are working as a control plane and worker both at the same time, because all these nodes are untainted. Okay, it means these control plane nodes can work as a worker node also. Okay, so I hope this is clear right now. Okay, so these are the all my internal IP. Let me show you the IP output here. So first layer, this is our first layer. This is my simple laptop, which here I have created the 2 VMs. Okay, Okay, so these are the two VMs, and how these three nodes are created. Basically, one node is physical machine itself, and two nodes are our VM nodes. Okay, so here let me go into deep into our IPA output, because this is the first key point from where our networking start. Okay, so here yellow you can see that this is the loopback address of this machine. This is the RHEL 9.7 itself. Okay, EN002 is the basically in down state, which is basically my the Ethernet cord. So Ethernet cable is not connected, although we have connected WL01, that is the Wi-Fi interface. Okay, by using this interface I can go to the internet. Okay, and BR0 is the our virtual bridge 0, that is basically what it's doing. It's basically sending my physical machine traffic to the both VMs. Okay, it means my both VMs communicate by using BR0. Okay, so that is the IP address here, 192.168.122.1. Okay, so this is the itself also nodes IP. Okay, VNet 0 will be used for communicating the node 1, virtual node 1, it means VM1, and VNet 1 will be used for the VM node 2. Okay, you can think like that. And planar 1.10 is the basically CNI. Okay, that we have implemented here. Okay, you can see that range is 10.244.0.0/32. Okay, so it's also up, and this is the CNI 0. It's basically our bridge, pod bridge, by which our this node, physical node, will communicate from the pod. Okay, so if you are not able to understand, then just think like that. This is going to happen. We will also visualize by using a actual diagram of this by networking. Okay, and what are these VTH? Like, let me show like why these VTH are here. These are the actual wires. You can say virtual wires, not the physical wires. It's are the actual wires that are connecting your this machine to the actual pod. Okay, it means one side is here and one side will be go inside the pod. Okay, so let me show you first all things. So let me show. So I have these pods running. These are the 6 pods. These are running here. Let me show you. Okay, so these are the IP addresses that are assigned to these pods. Okay, so these 6 pods are running. Some 2 pods running on each host, like these. Okay, so here like node. Okay, so 3 pods are running node 1 on node 1, and the node 2 is running 1 pod, and node 3 is running 2 pods, 2, 2, 4, 2, 6. Okay, so we have set the replicas at 6. Okay, 6 pods would run at a time, and we have also set the skew value to 1 only. Okay, so that's why only like every node should have only at least 1 pod running on every node. Okay, that is the minimum we have specified. So let me show you. So okay, so I will go here. So let me get in the next deployment, so you could not have any like difficulty to understand like why it's happening. Like we have replicas with 6 pods specified here. Okay, so here we are running 1 pod, 1 container inside our pod. Okay, I will also show the side containers, how side container communicate. Okay, so this is the my first thing that is running here. You can see that, and here specification is like topology space constraint is max skew value is set to 1. Okay, and topology key is like this. Okay, so you will go through that. Okay, and here I have also specified one more thing. You can see that this is the very interesting thing that is basically not recommended in your production, like security context here I have already set it to true. Why I have set it this? Because I want to install the TCP dump inside the containers, and I want to snip the traffic. Okay, without this I will not able to snip the traffic to show you actually how it's working. Okay, so one more thing you can check that, like here you can see that complete subnet environment. Okay, so here we have used the flannel. I already told you that is the network having here it's 10.244.0016, and flannel subnet will be like 240.0.1.1. it means our first node will have pods will get IP from 10.244.0.1 /24, and second will get from 0.2, and third will get from 0.3. okay, so how we can verify that? We can verify by using the JSON output. Okay, understand? Let me show you something more. Here it will give the very big output, so let me type it. Okay, basically here I want to show the CIDR itself. Okay, so what name dot meter data name, we want name, and also the CIDR. What's saying infected either expecting in the file. Okay, okay, let me grip that directly from. So here, so you can clearly see that this is the complete specification. Okay, so here we can let me grip directly. Okay, so this is the actual CIDR. You can see that like first node has 10.244.0.0/24, and second one has 10.244.1.0/24 and 10.244.20/24. okay, so it means pods are going to get IP within this range. Okay, so like in node 1 that will get IP in this range, and in node 1, node 2, node 3. So node 2 will get this IP, node 3 pods will get IP from this range or this CIDR. Okay, so for the proof of concept, what we can do, we can just run the here kubectl get pods -o wide. Okay, so here we can see that these all IP belong, these pods IPs belong from the CIDR1. Here we can see that, and these are node 2, so node 2 get IP from this CIDR, and node 3 get IPs from this CIDR. Okay, I hope now it's clear how these pods are getting IP. Okay, so basically it's defined in your CNI. Okay, so when you are creating the cluster, during the cluster creation you have installed a plugin there, and those plugins basically provides this range for every node. Okay, so After this CIDR is assigned, your ports will get IP from that range only. Okay, so you have to think that during this configuration, okay, these addresses should not be overlap with your other IP addresses. Okay, otherwise it will just when I have teach you the first part, then I have told you like every port should get a unique IP. Okay, otherwise Kubernetes networking requirement will break and you are going to be face the problem because there will be the network conflicts. Okay, so first of all I had showed you like all this, how these IPs are getting here. Okay, so now what we can do, so here let me one more thing, here I explained the basic. So here like we have all this beth, like beth, it means we have each beth is assigned. This is the just one int that is in this node. Okay, namespace, you can say root namespace, and one int will be added inside the pod namespace. So if you have to check that, then how we can do that? Okay, so here like 1 2 3 4 5 6 7 B pair is assigned. Okay, so let me one more thing, we will dig into the networking part. So first in first video, let me here so this is my snap of network. Okay, so let me also, I will show this by using graphically so that you have better understanding till networking like till by this point. So here open, so this is the my complete networking base level architecture. Here you can see that what I am telling, like we have some host VM bridges like in physical infrastructure. Okay, like is in my laptop I have BIR bridge 0. It's basically this sit on my host machine. It's my laptop that is has RHEL 9.7 installed. First node 1 you can think that, and this is the node 2. Okay, or VM node 1, VM node 2, it means this is the node 2, node 3 for our cluster. Okay, this is the physical machine BIR 0, and this is the virtual network 0, virtual network 1 for our both VMs, VM1, VM2, virtual machine 1, virtual machine 2, and WL0 that is providing basically the internet facility. Okay, on my laptop and also to my containers. Okay, by using this bridge, CNI bridge, and EN0 is down. Okay, basically my internet is down in my laptop. Okay, so now how this networking will gonna happen? All three will be managed by, as I already told you, the CNI plugin. Which CNI plugin here we are using? We are using the Flannel here. So Flannel uses the VXLAN. Okay, so this VXLAN will communicate directly with our virtual bridge for communicating to the other nodes. Okay, because our networking will configure to go with the VIR bridge 0. It's basically a bridge that we from which it's going to our other virtual machines. Okay, like node 2 or node 3. Okay, now this CNI bridge has provided this networking. Okay, here we are using Flannel. These will basically the same things. Okay, you can think that like, and CNI bridge will be used inside our single node. Okay, so this is, you can think this is the single node having multiple ports. So then if you are thinking our engine export 1, so how it can communicate with the other ports? It can simply communicate with by using this bridge. Okay, so inside a single network. Okay, so this is the root namespace here, and these all are the V8 pairs kernels. You can see the virtual pipes. Okay, like one side is in my V8, one side inside my host machine that I already showed you in IPA output, and one side will be inside the pod. Okay, one side will be inside the pod. Now I hope you are getting. These are the VETH pair. Why it's called pair? Because it's one side inside will be your host node and one side will be inside your pod node. And for local host communication, you can see that I will use a sidecar container, okay, to show this traffic. Like we will install HTTPD and we will basically call by a Ubuntu sidecar by using the curl. Okay, so I will also show you how. So they basically communicate inside the same pod. If you have multiple container, then they will use the local host to communicate from each other. Okay, and if pod to pod communication, how it will happen? From here that will go to the CNI bridge, and here CNI bridge officially there will be some routes here present here. Okay, that will basically route to network to the specified destinations. Okay, so these all things will be managed by the CNI bridge. I hope you have clear concept till that point. So here I already showed you the practically, okay, till this root and namespace. Okay, the one side will be inside the pod. So let me show you. Okay, so one more thing I want to explain here. So how node 2 and node 3 will communicate. So node 2, node 3. Now you know that inside the same node how they can communicate. They can use the VETH bridge. Okay. Now if we have a scenario like pod A of node 2 want to communicate with the pod B of node 3, then how they will communicate. Okay. So till that we know that there will be some VETH pair by which they will communicate with the CNI bridge. Okay. Inside the Linux namespace. Okay, all things will happen like inside Linux namespace. There will be some services, some routes will be there. Now they here once this Linux basically kernel will receive this packet, then it see like there is the some VXLAN encapsulation is there. Okay, so planner what basically they will send the traffic by using the VXLAN gateway. Okay, to this VIR bridge 0, because all things will communicate like this. How the my machine, how these two nodes are communicating by using the virtual bridge 0 1 to 22.1. It means that is the physical machine also. Okay, so that is the node 1. Okay, and this is the underlay network configured on node 1. Okay, this is the main physical network, you can think that, and this is the overlay here. I hope you are understanding. Like here, like it's basically comes inside the VX encapsulation will happen there, and that will go now. It's see the our node IP address. Now this bridge know like where the 122.20 is here, where the 122.20 is present. Okay, so it will route. Okay, so let me show you how this is happening. So here at this level I can show you the route hyphen and output. So it's basically know that. Okay, here you can see that 192.168.1.22.0. If you have to get like anyone can go to here. Okay, by using the VIR bridge 0. Okay, so if any IP of this range is coming for this complete destination like 122.1, 122. Till from 122.1 to 122.254, all traffic will go by VIR bridge 0 device interface. You can see that interface. Okay, so we will also see the practically, so don't worry, we are going to run the here Wireshark. So now this node IP, so here it will go here, and then it's get like there is some encapsulation is happen. So VXLAN packet is present there. When it's unwrap that basically, so it will now get the actual IP address of this port B by using this here. It's parallelly working with the container bridge that is basically provided by the CNI flannel itself. Okay, so it's know the actual IP where like this IP is present, port B's IP is present, so it will route to the port B. Okay, so this is the actual things that are basically comes in the picture, like how node 1 will communicate with node 2 or node 3. So basically node 1 is the host machine here in my case, so it can go node 2, node 3 by using the virtual bridge, and then after going inside that, they will use basically CLI networking, okay, to find the pod B, okay, IP address. So in that manner that are being communicated. One more picture I want to show you in this regards, so that you have complete clarity. So you can also think it's like here, if you have idea of Linux namespaces, okay, and Linux basic networking, then you can understand all these concepts, like what is going behind the scene. You can also do all these things that are basically done by the CNI from ourselves, but it will be very complex, okay, because pods are ephemeral in nature, okay. So every time it will like die and get new IP, so it will be the very complex. But here what we can do, like we can create by using all these things by using the Linux command itself. Like command here I can show you that, like here in 0 is by default down, so for WL01 we can add this in this manner. We can use the IP address add command, and we can assign this IPs by using this command, okay. So behind the scene, it's basically here it's using the command. We can do the same things by using the Linux command, so you should have idea of this, okay. So for better understanding of all the networking, what is basically like here host VM bridge infrastructure level, what is doing, it's basically creating a bridge for forwarding the traffic to my both VMs, okay. So here you can see that we have assigned some IP like this same range, okay, for forwarding the traffic to my VM node 1, 2 and VM node 3, that are the KVM host machines, okay. So VNet 0, VNet 1 can be configured by IP link set VNet 1 as master VIR 0 and this manner, okay. And then in root namespace for virtual fabric and CNI, we can use the IP link add VTHX type VTH peer name VTH0, okay, to configure all these things, okay. So for creating the CNI 0, we can use this command IP link add CNI 0 type bridge IP link address. We can assign the same IP addresses to the device CNI 0, and similarly we can also configure the planner interface, okay. So all these interfaces are present in my laptop. I already showed you the practical CNI 0, planner 1.1, and all these VTH pairs are also present, okay. So these are the net namespaces here that are basically isolated pod namespaces. Here you can see that IP net NS net namespaces add pod A, net namespaces pod A, pod sidecar, okay. All these things we can do by using command line. Here I already showed you by using the IPA command. All things are present here, okay. But here I have not used the command line. I have used the Kubernetes CNI final CLI for doing all these things, okay. It's always recommended to use the CNI, but for your knowledge, just I am showing you, like you can also do the same thing by using the command line itself, okay. You can manage all the things, okay. Behind the scene everything is being managed by the Linux, okay. So the all things that are being done by the Kubernetes we can do them manually also, but our purpose of studying the Kubernetes is to manage at high level, okay, without being stuck in this complex thing, okay. So you can think that like this is just for a very simple architecture, okay, that is being in my lab, okay. If you think like production setup that has multiple like thousands of microservices and pods are running, and with hundreds of nodes, so you can think that how cumbersome and how complex to manage by using the CLI, okay, if Kubernetes CNI will be not present, okay. So to minimize this complexity we are using the CNIs, okay. So So here this is the very simple CNI here I used in this lab, that is the flannel. Okay, so this is the basic first level of CNI. Okay, this is also not production ready, I told you. Okay, because here we cannot apply the network policies. Okay, by default all pod can communicate from all the pods, okay, on every port. So let me first I will cover the sidecar concept. Let me close this. I hope you have better clarity now what's going on here. So first thing first, we will show here intra-pod communication, that is the basically sidecar containers and localhost pod namespaces. For that you can just use this is my main one that is running here. All the deployments you can get here, all the deployments file is attached in this GitHub file. Okay, so let me first I will go with the localhost. I want to show this. So for this one let me copy the, okay, so I already have that file. Let me go here. Okay, Nginx deployment. Okay, HTTPD Ubuntu YAML. So what I will go do, like here I will run a HTTPD service inside a container, one container, and I will run a Ubuntu on the second container on the same pod. Okay, to show the localhost communication, and we will also sniff the traffic. So let me get for you so that you have idea like what is inside that file. So here you can see that API version app version 1. Here's metadata name is for internal demo. For replica we are going to use one. Match level is for local communication, application for local communication. Here one container has Apache server. Okay, so for that we are going to use the public HTTPD latest image, and container port we have exposed is 80. And for the second sidecar container from which we will access this, okay, we are going to use this. Okay, so we will install the curl there. Okay, so also I have added the capabilities in security context, net admin, net ROS, so that we can sniff the packages. Okay, so let me also I will add this here so that you can also do the practice if you want to do. Okay, so I have added that. So let me do one more thing here. So I will apply this deployment by using file -fg. You know that we use one file, so it's created. Or let me check. Okay, so it's container creating. Okay, so it's saying like here there are 2 containers are present in this pod, and currently no services or no containers are ready. Okay, so let me decide this pod. Oh, sorry. Okay, so it's running basically right now. It's running, so no need to describe, but we one more time we can check that. kubectl describe pod and pod name. Okay, so here it's you can see that all things it's pulled, already pulled. Okay, created, started, and currently it's running normal. Okay, so Ubuntu sidecar is also running fine, and Apache server is also running fine. Okay, so what we can do that, let me Ubuntu sidecar, our containers name are Apache server and Ubuntu sidecar. So here let me log in inside the container, kubectl execute interactive and the pod name will be, I already copied that, and container I want to copy, go into Ubuntu sidecar. Okay, so hyphen can go here. Okay, so let me first log in by default into Apache. Okay, so here I will specify the wrong one. Okay, so you can think that if you are engineer, then these are the parts. Okay, so we are inside the Apache pod. So here we have a service running on port 80. So let me check this curl is here. Okay, so curl is not here. So sudo, not sudo, we can use the apt get update and apt get install the curl. Okay, so here basically it will update the repos and install the curl here. Okay, once we will check from here and then we will check from the sidecar container. Okay, so it's installed. So let me curl to localhost on port 80. Okay, so it's saying it's basically able to reach the Apache HTTPD, and here it's showing its work. Okay, so it means here from the same container we are able to access. Let me exit from here, or we can just go into the second container. Okay, so here we can specify like our container name 2, that was what, let me check here. Okay, its output is not present here. So here let me first check that kubectl describe get ports kubectl describe port and port name. Okay, so here its name is Ubuntu sidecar. So we will directly this time log in into Ubuntu sidecar. Okay, so here we are inside our sidecar, that is basically the Ubuntu machine. Okay, so here we will again curl to localhost. Okay, curl localhost and port 80. So let me check. Okay, here it's also working from here. Okay, so it means it's all networking is happening by localhost and it's working fine. TCP dump is present here. Okay, TCP dump is not here. So let me install quickly TCP dump here. apt get install TCP dump. Okay, so it's installing TCP dump. So we will sniff the traffic. Okay, so for that we will use this command from our host machine. Okay, so here we can see that all communication is happening by the local host port 80. Okay, so here let me go. Okay, so here let me open one more terminal here. kubectl get pod. Okay, so from here we will copy the pod name. Okay, and sidecar name was let me here I will kubectl describe. It was Ubuntu image, I think. Let me describe kubectl describe pod. Okay, so it's Ubuntu sidecar. Ubuntu sidecar. Okay, so here we'll log in inside Ubuntu sidecar, and we will use the tcp dump command -i localhost. We will basically sniff the localhost traffic, and we will basically forward this localhost traffic to our buffer, localhost buffer, and here we will invoke in my local machine. I will invoke the Wireshark to immediately take the input from the buffer. Okay, so let me start. Okay, so wait for a few moments. Let's see Wireshark is starting or not. Okay, so let me check why Wireshark is main input could not load the Qt platform plugin even though it was found listening on a low length snapshot length itna. Okay, so here Wireshark is not loaded. Okay, so I think what we need to do, so what is saying main warning could not connect to display. Okay, let me export the display variable here. It means we have a login multiple time. Okay, so it's not a big deal. Let me one more time invoke the command. If it's still not starting, then we will execute from here. Okay, so I don't think it's coming here. So here it's login in default session. Okay, so why it's not loading here? Because we have, I already told you, we maybe on pipe music doesn't open. Okay, so just to go. So because here we have multiple times we have opened the multiple sessions. Okay, so it's not getting the basically display variable, so that's why that was not opening there. So let me close that and close this terminal so that you will not get confused, and I will just increase the size of this. And here in the file on pipe magic during open. So somehow it's not basically streaming. So what we can do that we can just check from here also. So for that checking that we can basically sniff the CNI bridge itself. Okay, so it will basically not come here. So what we can do, we have to check the yellow. So we can just do one more thing. We can just take a capture there, and then we can copy that capture here, and we can see that. Okay, one more thing, why it's not able to stream that, like we might require here, like to provide the complete root context to root access. So here let me, so here ls here cd teach ls get cd nginx. Okay, get to this nginx deployment. Okay, so we will specify the complete this security context to privilege is equal to true inside our STP Ubuntu YAML. Okay, let me specify the security context. Okay, so let me apply the okay, so we have reconfigured that. We'll check if our pipe is breaking or not this time. I hope it should not break. If it will break, then we will see. So this is the basic real-time troubleshooting. Okay, so you will also get idea how you can also, this is the real-time scenario. Okay, you can just replicate this if you are doing the same thing in your practical environment too, for better understanding. So let me here okay, again it's giving the in the file on pipe magic during open. Okay, so we will investigate this issue. Okay, so if this method is not working here, okay, so what we can do the alternate things here. So let me come here. So let me create a we can create a temporary FIFO here. Okay, so we can do right here. Let me create a FIFO queue. So MPK we will create a queue FIFO basically. Let me capture name is capture. Okay, so here we have create the capture FIFO, and what we'll do, we will just input a file to our TCP dump directly. Okay, so instead of directly feeding the stream, we will just feed the this. Okay, so it's started now without error. So one more thing we need to do. Okay, so let me here cut this. I will run this into background mode so that I can run the other commands here. So here one more thing, let me to run here. So we need to basically we will store the capture inside this FIFO. So kubectl execute pod internal demo. This is our pod name and container is Ubuntu sidecar, and here we are executing the TCP dump directly. That here we will write inside a file that's name is tmp capture. Okay, so here let me do the things. Okay, now it's forwarding. Let me send the traffic there. So here we log in inside the pod. So let me check, is traffic is coming here? Yes, localhost traffic is coming here. You can see that source and destination both are the same localhost. Okay, so let me increase the size so that you can get that idea like what is going on basically. So here this will be the gonna do the, here we have captured the east and west traffic in terms of networking and firewall security. So here you can see that when we let's check analyze this packet. So here for that we can just go into the analyze. We can follow the TCP string to see the here we can showing all those things like what is going on. So here it's saying here it's basically send a get HTTP 1.1 request. Get is the method and host is the absolutely it's the local host, and user agent is curl now, like it's this is sent by using the curl. Okay, otherwise you will see the browser name, and here accept is the slash. Okay, so here its response is 200. Okay, and server is Apache this and document type HTML. Here we are able to find like its work parameter here also, so that in that manner we can analyze the traffic. Okay, so here why we are able to read the content of this traffic, because it's not encrypted data. Okay, so here we are running the TCP dump inside the pod, inside the container 2. Okay, that is the sidecar container. Basically from here we are streaming the data of that sidecar to here. Okay, so this is the you can use this for troubleshooting in your production environment. If there will be some packet drop between your local host sidecars, between those you can analyze in detail here. Okay, so like if there will be some jitter or some duplicate packets are being sent, then you can also analyze from here. Okay, so in that manner you can analyze that by using this by implementing the FIFO, or you can directly also feed that, but I don't know by this time I am getting error, but earlier I have tried that and that method was also working. Okay, so FIFO is the more stable thing, you can do that. Okay, so here you can also follow the HTTP string. Okay, but generally information is the same, nothing is changed. Okay, you can save print as per your requirement. Okay, so here you can see that it will send one more time traffic from this. Okay, so you can one more thing you can notice that this is the our sidecar container, and our main container HTTPD container is separate container. Okay, running inside the same pod. Okay, that I already showed you. So here one more time we have sent out the traffic, so it's from PS here. Okay, so here we can also analyze the packet. Why? Because this is the completely encrypted transmission being happen. So anything that will go inside that, okay, we can able to see that. Okay, if any data is going, okay, like here data is going inside the TCP HTTP packets, so here we are able to see that. Okay, in that manner. Okay, so source port, every information you can see that. Okay, here. So as per your requirement, you can use this for the troubleshooting the networking or packet related problems. Okay, so that is the things. Now you can see that how internally this traffic is going. Okay, so here nothing more technical. Okay, so let's move to the second part. So here I am closing the Wireshark. Stop and quit without saying yes, or you can stop and save that. Let me give the name localhost. Okay, traffic capture sidecar. Okay, so save that. Command is executed successfully. Okay, so let me also here delete this sidecar. Okay, so here you can see that this first objective is completed. So how these are working basically inside the same pod. How do two containers communicate? They use the localhost communication. All traffic is being encrypted. Okay, if you have not maintained HTTPS, if you have also terminated your like HTTPS at cluster level, then also the traffic inside that will be the in plain text only. Okay, so let me see here. Okay, so it's terminating. Now we have multiple here containers. So here we have the Nginx server. So here what is my objective, like get pods. Let me show you. So here we have like node 1, this container. Okay, so I want this time to show the communication between node 1 and node 2, this container. Okay, so it's basically container, it's a singular of container A on node 1 and container B on node 2, how they will communicate. Okay, so they will basically the routing will be, all routing will be happened by the bridge 0. Why this bridge is used, like here I already show you. So this behavior bridge will be used for this communication. Okay, behavior bridge 0. Okay, and here we can also, if you want to see the clean traffic, then we can use the VNet 1 interface for seeing those communication. Okay, so here what we will do. So let me just go into that container, inside that container, and install the curl. Okay, if not present there, and also I will require the TCP term also to be installed there. Okay, so let me do the same thing first, then we will move further. So this I already have pasted this code here inside the GitHub repo. Okay, so you can also apply for your lab. If you don't know how to create the 3-node cluster, then there is also a video how you can create the Kubernetes 3-node cluster. All nodes are working master, at the same time also working as a worker node. Okay, so let me go here first, install those things. Okay, so it's fine, all are running properly. Now just we will pipe use the pipeline and pass the some arguments here. I provide the input. Sorry, can I to kubectl execute. Okay, so it will basically, what will do, it will just basically take all these things here. Okay, first let me control. Okay, let me use the pipe operator. Execute the apt get did and apt get install ny tcp dump and also the curl. So I hope command is correct. Okay, so it's basically what it will do. Basically it will install the tcp dump and curl on all nodes. Okay, sorry, on all nodes or container. Okay, because here we are running one container inside one pod. Okay, one pod is running just a single container. Also this is the best practice, recommended practice, although we run the sidecars as per requirements. Okay, so wait, it will take some time to be installed all things. Although we'll let me show the traffic, capture the traffic at this moment. Okay, so I will run the Wireshark and I will capture the bridge. So here what I will capture? I will capture the complete bridge. Just okay, so here you can see that all traffic is going inside that and outside that. How it's basically now it's communicating from the internet to install the packages. Okay, so here we can see that it's basically communicating all 2.8, 2.8, 2.9. It's also communicating internally. Okay, so here you can see the all the traffic captures by 122.1, 2.8, 2.9, all the participants, because we are currently capturing the our bridge. Okay, so this from this bridge we can see that all the traffics that are basically going inside that or outside that. Okay, on this form. Okay, here we are able to only see the node's IP. Why we are not able to see the pod IP? Because it's basically encrypted inside the packets. Okay, so for that if we stream application data here, let me here, so source type is RHEL-based. Okay, transmission control protocol, let me see, source port is 2380. Okay, it's a command completed, it means it's successfully installed. Meanwhile, let me here we are analyzing a very transport layer security. Okay, so here it's containing some encrypted data. Okay, so let me check one more thing. So if you have to okay, so it's right now it's completed, command is completed. So at this interface we are only able to see the internal communication that is being happened within the nodes. Okay, cluster nodes, within the cluster nodes like node 1, node 2, node 3. Okay, like this is the node 1 communicating with the node 2, and here node 2 is communicating with node 1. What is saying application data, and then it's saying sending the acknowledgements to that. Okay, so here this is basically this interface will show the complete node to node communication. Okay, across the cluster. So if you want to see the application data is obviously it's encrypted with TLS version 2, so we are not able to see that, but let me analyze, try to follow the TCP stream. Okay, so it's encrypted because this time traffic is being sent over the TLS. Okay, so we are not able to read any content here. Okay, so here let me close that because its data is encrypted, so you can only see the source and destination at this interface that are being just happening. Okay, let me do one more thing. So here if I will close this capture, let me close this capture. Yes, I store without saying. Okay, so let me one more time. I want to show, if I want to show the public communication. Okay, so just execute that command one more time, and here Let me do the one more thing, TCP. So Wireshark, this command will complete very fast. So this time, which interface we are using to communicate with the internet is actually WL01. So let me capture the traffic of that. Okay, so here we are connecting from the internet. Okay, with the Debian. Okay, so here we can see that this interface is I already showed you my interfaces, but one more time I will show my interfaces here. So which interface I am using to connect with the internet is the Wi-Fi itself. Okay, that interface name is the WL01. Okay, so this is my Wi-Fi interface. Okay, so here when we are going there, all the data is going that we are currently updating is going to the internet. So here we can see the clear communication between our host machine and the internet. Okay, it's basically the Ubuntu. Okay, so here if we try to see the package, so this time now we are just capturing the what traffic. It's we are capturing the north south traffic. It means traffic is also going inside to outside and from coming from outside to inside. Okay, so this is just going from inside machine to outside machine, and here you can see that it's coming from outside to inside. Okay, so here application data, that is TLS encrypted, so absolutely we are not able to see that. Okay, but let me try to follow the TCP stream. So it's basically encrypted data, so I know that we are not able to read that. So close that. So in that manner we can see that how traffic is flowing basically in my setup. So let me show you the traffic flow between those machines. So here it's all packages are updated. What is saying? Not found. Okay, so I know this video is going to be very long, but this is a practical session, so you have to read that completely. So you have to do the things. Okay, so in that manner, so I will just log in inside the Nginx this container. So kubectl execute. Sorry. Okay, so here I have gone to this pod, and here okay, so we have inside this pod. So let me curl local host 80. So here Nginx is working fine. Okay, so we will also curl to the IP. So let me here open a one more window, kubectl get ports -o wide. So this time this is node 1, this is on node 2. Okay, currently we are inside the node 1. Now we want to curl node 2. Of course we are able to do that. So this is the IP address that we will curl from here. Okay, so this is also working. So how this traffic is flowing? So if I have to capture then that we have to log in on node 2 or node 2 container here. From here I will just So just I will copy this command and I will write to Kubernetes captures. Sorry for that. So from here let me run the Wireshark TMP capture. Okay, so here command is present. So I need to change this with the IP with the node 2 name. So node 2 is this container 260 and okay, so let me open the Wireshark. Okay, so here let me open the Wireshark here. So input file name will be like tmp capture. Okay, end of file. Okay, fine. So here it's forwarding basically. So curly command, this is here. TMP capture, TCP dump not found in path. Okay, so it's saying TCP dump is not present there inside this container. So let me check. TCP dump is here or not. TCP dump. Okay, TCP dump is not present here. Why it's not present here? Although we have tried to install that. So this is the one. So let me try to be login onto where are you, bro? First second. Okay, so main base execute. Okay, apt get update and apt get it install y tcp dump. Okay, so get so once this will complete, then we will quickly check the node port service, how we can configure the node port service, and we'll also sniff the traffic of that, and also we'll say the working of VIP. Let me check TCP dump is working fine here. Yeah, now it's working. So let me close here. Let me start the Wireshark. From here I will start the Wireshark. Input will be inside TMP capture FIFO. Okay, TMP capture. Okay, so it started successfully. So let me send some traffic there curl and port 80. So here we can see that we have some packets with the ports IP addresses here. Like this communication is happening between the 11 point this to this. And also one more thing, we can just start to Wireshark one more window. So let me open this. Okay, so new window. Let me open the new window. And so here we are going to the node 2. So here VNet 0 will be used. Okay, so let me open the VNet 0 and try to find what things here. So here all the things are going between node 1, node 2, node 1, node 2. Okay, all the communication are being happen. So let me try to analyze. Okay, so packets, so here we can see the packet has multiple format or characters, we can say that. But here this is also encrypted, but here at this level we are able to only see that this communication is happening from node 1 or like node 1 to node 2. Okay, at this level, and what we are able to see inside that container. So inside that container it's basically saying this. Okay, inside that container we are I hope we are able to see the packets directly. So here we will see that in unencrypted packets. Okay, here it's the basically host is 10.2.4.1.7, that is the basically will sit on the node 1. So here it will check this output. So it's the 244.17 is on node 2. Okay, so it means we are sending this traffic to node 2. Here we are also captured this from node 2. Okay, so from where its traffic is coming. So let me check where the, because both sides will be present here. So here when we open this packet, so it's coming from 244.0.11. 240.11 is like here. Let me check the IP. 240.0.1 is node 1's this container's IP, or this pod IP is this. Okay, that pod is basically present on node 1. Okay, with the IP 10.244.0.1. So traffic is coming from here and it's basically going to 244.1.7. Okay, so here we can see that we are able to, here when we see the capture, its traffic is basically unencrypted. Okay, and also one more thing, here we are able to only see the ports IP addresses. So here when we run the Wireshark here, so here we are able to only see, because which interface we are listening on VNet 0, sorry. So VNet 0 is attached with the node 2. So here we are able to see the communication between the this 122.1, that is also bridge IP, and our physical server IP. So that's communication is happening between these two, and here all packets are encrypted. Also here we see that this are the encapsulated packets. Okay, so here we are not able to see the ports IP. Okay, it's basically get unwrapped inside the CNI. Okay, in kernel namespace. So here if we want to see the data is absolutely it's in encrypted form. Okay, so it's contains some payload of 93 data. It's basically encapsulated data. Okay, so let me one more thing, we can apply one more filter here. Okay, so here one filter is already applied. TCP only, UDP only, and display no IPv4 only IP. So these all traffic are basically encapsulated. So I hope you are getting the points. Okay, here you can see that this are this at this level only physical, it means MAC and IP addresses are in place. Here we are able to see only that, and encapsulated data is not visible here. Okay, because at this layer it's basically encapsulated and wrapped. Okay, so when we capture this here, we are not able to see that, although we are here when inside the pod we are able to see these IP source and destinations. We are not able to see the nodes IP addresses. Okay, because here data is encapsulation is unwrapped here. Okay, and here also traffic is not encrypted, so we can read the data. Okay, TCP stream or HTTP stream. So that's it. Now you can think that how traffic is basically going and communicating behind the scene. Let me use the one more thing. So the okay, we are inside here. Let me use the NS lookup, which NS lookup is present here. No, so let me install the NS lookup here. apt get install NS lookup -y. Update and apt get install. Okay, so here I will show how the basically one more important concept is here. Like from 4 pillars, we have already covered the 2 ones. So here I will show the how service discovery work, which basically it's a DNS based record management system. Okay. Then we will also check the service networking like VIPs, node pods, and of course we know the load balancer, but here I will not cover the practical. We'll see in future video because this video is getting very long. Okay, so here quickly I will show the how notepad and VIPs work, and then we will wrap this session. Okay. Okay, so NS lookup is it's part of some package, I think. So what is the package name? Okay, so it's a part of which I guess DNS util. Okay, let me check. Okay, so here let me use the NS lookup. Okay, so here these all points are completed. Okay, so here we can see that we have a service name Nginx service. So how it's basically retrieving the IP. So its IP is like this, port 53. So let me close this because our these sessions are completed. So this is capture 192, so we don't want to save that. Yeah, I close that, and here this is capture from port 2. So if you have to show the service discovery, it means I have to, okay, it's originating from the node 2 pod. So let me quickly log into kubectl get pod. One more thing, first of all, I will show ls here. cd teach nginx ls here. So we have work here, that is our my nginx service.ml. So here you can see that this is my nginx test service. So what is these services basically? So this we know that all are ephemeral in nature. So for maintaining the good communication and consistent communication from our internal pods, so we use the mostly the VIP. So also node port uses the internally VIP for the service discovery. So node port, when we have to communicate basically from the external services or to the external world, then we basically use the node port. But in production environment generally it's avoided, but for concept you can know that. So here I have used the nginx test service. Okay, so here nginx test is deployed. So let me quickly kubectl get is services. So here you can see that we have the node port service running here, and also its name is nginx test service. Okay, so when we'll use like ns lookup here, let me, this I am running and my host node 1, ns lookup and the service name, that name is nginx service. So it's basically resolving that. So behind the scene, how service discovery works. Service discovery basically uses the DNS entry. Okay, so all these information are stored where? So etcd, inside etcd. Okay, so all the configuration, it's just like a vault. So basically this is the node port. So when we want to access any service on any node, so here it's basically exposing over the 30080. So there are some range that node port uses to expose. Basically what it's do, it's basically bind the specific port, okay, on every node. Okay, so when we use like curl and IP of node 2, let me I give the node 2 or node 3, node 2, suppose I have given node 2 and the port 30080, then here we are directly able to reach to our nginx, that is on node 2. Okay, although here a direct connectivity is there, but if that connectivity is also not present there, then also we are able to access by using that port, that node port. Okay, so that's why its service name is node port. Similarly, we can access on node 3 also this port. Okay, so because we have binded the 80 port number 80 of every node to this port number 30080. Okay, so that is the concept of node port. Okay, so I hope you get that. It's basically work over the, it's basically internally uses the VIP. So let me show you the kubectl get svc. Okay, so right now we have the only one service running node port. So let me delete this service. So kubectl ls first of all here. So kubectl delete file name is nginx and svc.ml. Okay, so we have deleted this. Now just we will use kubectl and we will apply -f, and here right now we are going to use the VIP. So here okay, so nginx internal vip.ml is present here, so I will use that. So it's created. So let me check the this type service. So here this service type, this time when we run the kubectl get service, the service type was the node port. Now it will be the cluster IP. Okay, so now cluster IP is just change the cluster IP. This is the cluster IP. So Node port has also used the cluster IP, basically VIP. You can see that this is the VIP, okay. But this is the just a type is also cluster IP, and this is the internal VIP, okay. So it means now there is no port here. You can see that is mapped, okay, to our nodes, okay. So what is the difference between this node port and this VIP service? It's basically managing all the ports networking behind the scene, okay, by it's provide the cluster IP. So we will communicate by using this cluster IP only, okay, and Kubernetes will do the rest of things, okay. Like here, if you want to go on any port A, port B, port C, okay, so we just specify the here we use the virtual IP to access that, okay, inside the cluster. So here you can clearly see the difference between node port and cluster IP. So let me try to hit this cluster IP by using curl. Okay, so that let me see what we are getting on port 80, because it's exposed on port 80. So it's saying, oh my god, this is the your Nginx server. Okay, so it's working fine. Thank you for using Nginx. So what is the use of this? So right now, just this is the complete cluster IP. Okay, now everything. Now it automatically sends the traffic to the pod that is basically healthy. Okay, and also it's check behind the scene. So we don't want to now aware with the how many pods are running behind the scene inside the cluster. We have just one VIP to access all the services related to those pods that is selected in the selector. So when I will show you the what is the content of this. So okay, so here it's basically here you can see the its kind is service metadata Nginx internal VIP cluster type is cluster IP selector is Nginx text. It means all those pods that has the same label Nginx text will get selected here, and all those are just exposed by this virtual IP, okay, that here I already showed you. Okay, so how this virtual IP is resolving? Virtual IP is being resolving by using this DNS records, okay, that is basically maintained by the Kubernetes RS behind the scene. Okay, so I hope you get all these points. Okay, so all these things are being happen behind the scene. Okay, it's basically using the service discovery by using the DNS, and VIP is just managing the providing us a single point of contact. Okay, it's saying basically for these all labels of pods I will provide a single IP, so you don't have to go to the individual pod for accessing the services. Okay, so just come here and use the port 80. I will do the things. Okay, so here you can see that ports are here in protocol. It's mentioned TCP and port 80 the VIP port for internal access, and target port 80 the port on which pod has exposed the services. Okay, so that's it all the Kubernetes networking part. Okay, so guys, wrapping up this demo. Okay, thanks for watching. Have a nice day to you.